Hey everybody, Vade here, and today I'm going to be proving the rest of our trig derivatives. So that is tangent, and then our reciprocals like cosecant, secant, and cotangent. So let's get to it. So let's first start off with tangent here. So we know that for tangent, right, d dx, let's just say, yeah, tangent of x, right, that's the same as d dx of sine of x over cosine of x. So let's just recall here, right, from our previous videos, right, d dx of sine of x equals to cosine of x, and then d dx of cosine of x equals to negative sine of x. So if you don't know how I got these, please watch the previous videos in this series, because I go over how to derive both the derivative of sine and cosine using the limit definition of the derivative. So make sure to watch that if you do not know how I got these or do not understand how I got these. Anyway, so how do we actually evaluate this derivative here? Well, we're going to use our quotient rule. Now, again, the quotient rule, hopefully you know it already. If you don't, you can watch my first ever video in the series, which goes over how to derive the quotient rule alongside the product rule and power rule using logarithmic differentiation. So if you have not watched that or do not understand or do not know the quotient rule, make sure to watch that video. So using our quotient rule, we'll do bottom cosine of x times the derivative of the top, which is also cosine of x, plus then, or minus, sorry, minus top times the derivative of the bottom, which is negative sine of x, all over bottom squared, which would just be cosine squared of x. So then we'll get cosine squared of x plus sine squared of x over cosine squared of x. And hopefully you understand that cosine squared of x plus sine squared of x equals 1. That's one of our Pythagorean identities. If you do not know how I got that, please watch the video. I'm pretty sure there's a video in the series which goes over how to derive the Pythagorean identity, so make sure to watch that. So then this will just be 1 over cosine squared of x, which will then just equal to secant squared of x. So we can say, therefore, d dx of tangent of x equals to secant squared of x. Okay, so that is the derivative of tangent of x. Pretty straightforward, just using our rules of differentiation and knowing that the derivative of sine of x is cosine of x and the derivative of cosine of x is negative sine of x. So now let's go over our reciprocal derivatives here. So there are many ways to do this. Hopefully you understand that you just got to use a trig identity and get it in terms of like sine, cosine, or tangent. So in this case, let's start off with d dx of cosecant of x. So again, many ways to go about this. Use an identity. I'm just going to say that it is the same as d dx of 1 over sine of x. Okay, it's because cosine of x is the same as 1 over sine of x. So now we can actually use our power rule here, and how we can use our power rule here is we can say that this is the same as d dx, and I'm going to just use brackets here, of sine of x to the negative first power. Note that this is not the same, sine of x to the negative first power is not the same as sine inverse of x. Okay, these are not equal to each other. Okay, now this raises like the argument of, oh, well then is sine squared of x the same as sine of x squared? Well, yes, this is a true statement. Again, I don't know why people really write it this way. Of course, it's to save time, but it's, I don't know. It's a whole other argument here, so I'm not really going to talk about that. Just know that sine of x to the negative first power is not the is not the same as sine inverse of x. Okay, so those are not the same thing. So anyway, here is how then we can use the power rule here, and of course the chain rule as well. So this will be the same as -1 sine of x to the -1 minus 1. Okay, and then that times the derivative of the inside, of course. You always got to remember that, of course, extended power rule. So then times the derivative of sine of x, which is then just cosine of x. Okay, so then now we'll then get -1 sine of x to the -2 times cosine of x. So then this will then just equal to -1 over sine of x squared times cosine of x. And then this will then equal to, and this is how it's commonly written. I'm just going to write it as negative cosine of x over sine of x times 1 over sine of x. And then this will then equal to, well, cosine of x is cosine of x over sine of x is cotangent of x, and then times 1 over sine of x is cosecant of x. Or people usually write it as negative cosecant of x, cotangent of x. So we can say, therefore, d dx of cosecant of x equals to negative cosecant of x, cotangent of x. So the trend that you really want to notice here is with the sort of with the derivatives that start with the right? Like the derivatives. Those are always negative. So that's a good way of remembering these derivatives, like co-derivatives. Derivatives. Let me fix the spelling here. The co-derivatives are negative. Okay, the co-derivatives always are negative. Okay, just a good thing to know, right? Right. Like if you're confused, oh, is it positive cosecant x cotangent of x, or is it negative cosecant x cotangent x? We'll just know that, oh wait, it's the derivative of cosecant x, so it has to be negative cosecant x cotangent of x. Okay. Anyway, now we're going to go over the derivative with respect to x of secant of x, and we're going to use the same sort of philosophy here. So I'm going to say that this is just the same as the derivative of 1 over cosine of x. Again, reciprocal identity. This is the same as d dx. I'm going to use bracket here again. Cosine of x to the -1st. Okay, remember, not the same as cosine inverse of x. Just had a whole conversation about that. So then this will then be the same as -1 times cosine of x to the -1 minus 1, again power rule, times derivative of the inside. Never want to forget that, okay? Chain rule is often very easy to miss with power rule, the extended power rule, especially if you do not put the parentheses here. Again, the parentheses here almost always helps you remember to apply the chain rule here. So even if you have like derivative with respect to x of, or let me say a brackets like x squared, still like 2 times x times dx, like still, it's good to do that mentally at least, just so you know that you should always apply the chain rule. So then times the derivative of cosine of x, which would then be negative sine of x. Okay, so then this will be -1 cosine of x to the -2 times negative sine of x. We can, skip ahead, cancel these negative signs here, and just get cosine of x to the -2 times sine of x. And this is already a good sign because this is secant. This is not cosecant. We have a positive sign here. So that means that we're on the right track. Okay, and then we'll have Again, this can be written like as this, or the common way it is written at is 1 over cosine of x. We can say like squared here. We can keep writing. Doesn't matter. Sine of x. This is commonly rewritten as 1 over cosine of x times sine of x over cosine of x, and hopefully you realize that sine of x over cosine of x is just tangent of x. So then we should get secant x. Tangent x is our answer. Okay, so we can say then, therefore, d dx of secant of x equals to secant of x, tangent of x. Okay, so now let's do our final one for today, the derivative with respect to x of cotangent of x. Once again, I know I'm not covering inverse trig derivatives here. I'm going to do that in another video. In fact, the proofs for the inverse trig derivatives are really cool, so I'm just going to save that for another video. It's much more visual, I could say. Not visual as in like graphically, but visual as in we're drawing a picture sort of thing. So I'm going to say that for another video. So anyway, same thing. That's just same as d dx of 1 over tangent of x. Now, one thing, I know I'm just going to add like something new every time. Like, one thing you may have noticed here is that if you do d dx of like 1 over tangent of x, you could use the quotient rule still. Okay, you could still do like bottom times the derivative of the top, which is 0, minus top times the derivative of the bottom, which is secant squared x all over tangent of x squared, and simplify. Like, you can do that as well, but that's just, I don't know, that just seems ugly to me, I guess. I don't know, like, it feels like there's a better, more presentable way of doing it. I don't know. This is completely correct. I don't know, I just, for the sake, like, again, I'm not just doing the problem, I'm teaching it to you guys, so, like, just wanted to make it more, like, I don't know, you get what I mean. So, in this case, we can write it as d dx bracket, again, tangent of x to the negative 1, not inverse, remember that. So then this will be the same as negative 1 times tangent of x to the negative 1 minus 1 times then derivative of the inside, tangent of x. That, remember guys, is secant squared of x. We just proved that in this video. Okay, so now we'll have negative 1 tangent to the negative, tangent of x to the negative second times secant squared of x. Already a good sign here that this is a negative 1. So then, since it's a cotangent, right, because the derivative is going to be negative here. So now, again, many ways of sort of thinking about this here. You could write it as, right, secant squared of x times 1 over tangent squared of, tangent squared of x. Many ways of writing this. I'm just going to say that this is, what do I want it to be? We can do 1 over cosine squared of x. I'm right now problem solving, by the way. I know the derivative in my head, but like I'm testing out like how we can get the desired outcome. So this should then be cosine squared of x, over sine squared of x. It should be negative, by the way. Negative. And this should then be, these two will cancel, and we get negative 1 over sine squared of x, and then that will then equal to negative cosecant squared of x. So we can say, therefore, d dx of cotangent of x equals to negative cosecant squared of x. And once again, it's negative, it's a co-derivative, so that, again, just justifies why, like, the co-derivatives are negative. Okay, good thing to know. Okay, just good thing to know if you're having trouble recalling these other trig derivatives. Okay, the key to this, again, if you are like really stuck, is know the derivatives of sine and cosine. Those are really easy to remember. If you really don't remember the derivatives of sine and cosine, use your limit definition to get it. Okay, if you really don't remember the limit definition, then try to visualize or watch my picturing limit definition video and solve the secant to tangent line problem. I mean, that's how deep you can go. But hopefully it doesn't come to that. Hopefully just recall that the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. If you do not know how I got those, I've made videos about videos about videos. They all build up, so just watch them, alright? Anyway, I'll see you in the next one where we do inverse trig derivatives, because those are super cool.